Worksheet number 10, looking at the first question, find the length of the arc on a circle of radius 10 centimeters intercepted by a central angle of 20 degrees. Well, visually, what this problem is describing is a circle that has a radius of 10 centimeters, and it's talking about an arc on that circle, which is intercepted by a central angle of 20 degrees. Well, the arc is a portion of the circumference. So I'm first going to find the circumference of the circle, which is 2 pi r. Since the radius is 10, this will be 20 pi for this particular circle. Then I have 20 degrees out of the total 360 degrees of the circle that I'm dealing with. So my arc length will be that proportion of the circumference, 20 pi. I can do some simplifications here. 20 over 360 is 1 over 18. 20 out of 18 reduces to 10 over 9. So this entire length is just 10 pi over 9. Moving on to the next one. Find the area of a sector of a circle with radius 4 centimeters. Again, visually, here's my circle. It has a radius of 4 centimeters. And I'm trying to find the area of a sector of this circle, which has an angle measured in pi over 3 radians. Well, in a complete circle, there are 2 pi radians. So I'm dealing with pi over 3 out of 2 pi radians in the sector, which reduces to, my pi's will cancel out. I have 1/3 times 1/2, which is 1/6. So I'm dealing with 1/6 of the circle in this sector. The area of the whole circle is pi r squared, which would be 16 pi in this case. So the area of my sector S is this proportion of the circle I have, 1/6, times the total area, 16 pi. Again, I get some reduction. This is 8 over 3, which would be 8 pi over 3. That would be the area of my sector. Determine the exact values of the 6 trigonometric functions of an angle whose terminal side passes through the point -5, -2. Well, I'm going to do a quick sketch to get a visual idea of what we're talking about here. -5, -2 is -5 in the x direction. So we'll be over here at -5, down -2 in the y direction. So here's the point that's on the terminal side of my angle. So this is really giving me this reference triangle, which has lengths -2 and -5 as its sides. And I'm trying to find this reference angle to get my overall angle. So I need to find the trig values of each of these. So sine of theta, cosine of theta, tan of theta, secant of theta, which I will link with cosine, cosecant of theta, and cotangent of theta. Well, in order to find those out, clean this diagram up a little. I'm also going to need to know the length of this hypotenuse. I know the length of each of the sides, but in order to find the hypotenuse, I'm going to use Pythagorean theorem. -2 squared plus -5 squared will equal the hypotenuse squared. So 4 plus 25 equals the hypotenuse squared. 29 is the hype squared, so 3 rad 3 equals the length of my hypotenuse. Now if I want sine, it's going to be opposite. Opposite this angle is -2 over the hypotenuse, which is 3 rad 3. But I can't have radicals in my denominator, so I'm going to have to multiply this by rad 3 over rad 3. And when I simplify out, I get -2 rad 3 over 9. Cosine, I'm going to do a similar process. It's going to be -5 rad 3 over 9. Tangent, opposite over adjacent, so that's -2 over -5, which simplifies out to just 2/5. And then each of my reciprocal functions is the reciprocal of the values I just found. So that will be 3 rad 3 over negative 2, or negative 3 rad 3 over 2. Cosecant, the reciprocal of cosine, will be 3 rad 3 over negative 5, which is negative 3 rad 3 over 5. And then cotangent is 5x. So I have each of my 6 trigonometric values here. Determine the exact values of the 6 trigonometric functions of theta if the secant of theta is 17 over 8 and the tan of theta is 0. First, I'm going to figure out which quadrant I'm in. Well, here, secant is positive. Since secant is 1 over cosine, this would also mean that cosine is positive. And I also know that tan is negative. So looking at my quadrants, a smart trig class should know that when cosine is positive and tangent is negative, I have to be right here in quadrant 4. So this is where my terminal side is going to be for this angle. My secant, which is 17 over 8, would mean that my cosine of theta is 8 over 17. So my adjacent side for this reference triangle is 8, and my hypotenuse is 17. You may recognize this as a 8, 15, 17 special right triangle. If you didn't, you could use Pythagorean theorem to find out that other missing side. And now I can find all of my remaining trig values. So sine of theta will be 15 over 17. Cosine of theta, which was the reciprocal of secant, is 8 over 17. Tan of theta is 15 over 8. Cosecant theta will be 17 over 15. Secant theta, which was given to me, is 17 over 8. And cotant theta will be 8 over 15. There's each of my 6 trig functions. Next, evaluate all 6 trigonometric functions at a given angle without the use of the calculator. That means I'm going to be having to use some reference angles here. 300 degrees is going to bring me around, before you even start any of this, you should keep in mind where your special angles are. 0, 90, 180, 270. So 300 is going to be in quadrant 4. It would be over here. And since 300 degrees is just shy of 360, it's 60 degrees shy. My reference will be at 6 degrees, the angle that will have to complete that full circle. So my reference angle of 60, then I would plug that reference angle into each of the 6 trig functions. So that will be, if I write them out, sine theta, I'm just going to do the main ones. Cosine theta, tan theta. For each of the other values would just be its reciprocal. So at 60 degrees, I would get sine of 60 is rad 3 over 2. Cosine of 60 is 1/2. And tan of 60 is sine over cosine, which would be rad 3. My next one, 3 pi over 4, well now instead of degrees, we're talking about radians. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, 3 pi over 4 is a little bit short of 1 full pi. So I'm going to be in my second quadrant. And it is 1/4 short of 1. So that will leave me with a reference angle of 1/4 of pi. So if my reference is pi over 4, well, again, let me just continue on to here. Pi over 4 for each of these. Pi over 4 is 45 degrees. So this is going to be rad 2 over 2, rad 2 over 2, and 1. Now, keep in mind that the secant, cosecant, cotangent would be the reciprocal of each of these given functions. So the same number is just reciprocal. And my last one, negative 5 pi over 6. Well, again, 0, pi over 2, pi, 3 pi over 2, 2 pi. 5 pi over 6 is just short of 1 again, so you may be tempted to say, oh, well, it's in quadrant 2. Do not forget that it is negative, so instead of going in my normal anti-clockwise direction, I will go in my clockwise direction, and just short of 1 pi, leave me right here. I'm 1/6 short of pi, which means my reference angle is pi over 6. So again, I'm going to tack this on here. So I get my final values, pi over 6. For sine, well, pi over 6 is 30 degrees, so it'll be 1/2. This will be rad 3 over 2, and this will be 1 over rad 3, which is rad 3.